I'm excited to tell you a little bit about our wastewater treatment center at Evonik, but before I do, I'd like to give a little bit of background about myself and actually how I got this internship, because it's kind of a funny story. So I am currently a senior in chemical engineering at South Alabama. I'm also a research assistant. I'm working on my second degree. I've already completed a bachelor's degree in biomedical science, and I've been married almost 2 years. I actually heard about Evonik through some interns that go to my school at the University of South Alabama, and they always had really great things to say about Evonik, and they always had interesting stories to tell. So I started to aggressively look for internships, and I wanted to land one, and I got excited. I saw one online, and the internship was posted for a computer or electrical engineer. And I thought to myself, well, I know PowerPoint. So I went ahead and applied, and shortly after I was actually given an interview. I remember sitting down during the interview process, and I said, I really appreciate you pulling my resume, but I'm shocked because of my background. And so he let me know there may be something coming up in the environmental department. But anyway, it was a long shot, and I didn't think anything else of it. And shortly after that, I was given an official offer letter. So I accepted. I remember coming on site day one. I was prepared to take on whatever a computer or electrical engineer does. But much to my relief, I was partnered with my mentor, Bill Klutz. He works in the environmental. He's an environmental manager in our environmental department. And so I was thrilled. I was not only at the employer of my choice, but also working in my area. And so I've been working in the environmental department for almost 2 months now. And I've been working in the wastewater treatment system. So I'd like to tell you guys a little bit about an overview of our wastewater treatment system and then my specific roles within that. So our wastewater treatment system can be broken up into really as many pieces as you want to. But just to keep it simple and do a pretty decent overview, I have eight steps listed here and a little schematic to keep all the pieces in one place. And then after this slide, I want to show you each unit as we move through. So we start with an equalization step. What happens is we process about 1.5 million gallons of wastewater per day. And so we collect these from all of our sites. And they wind up in an equalization tank, and it's just stirred. We're looking for uniform consistency. The wastewater is then shipped to our first real treatment center, which is our aerobic biological treatment. And they're highlighted in yellow here. They're extremely important. So we take advantage of microorganisms' biological systems to break down the organic matter within the wastewater. So we have two systems that take care of that. We have our CMAS. This is our continuous mixed activated sludge system. We call it CMAS. The same thing's occurring in the oxy ditch. We needed a way to distinguish them. Each of these tanks are about 2.77 million gallons, so they're enormous. And so what happens is the organic waste is introduced into the system, and the microbes begin, they have an organic matrix they sit on the sludge, and they begin to break down the waste in the wastewater. Once that has occurred for a given amount of time, we actually move to a clarifier unit. And so what happens is we have it's really a sloshy mixture, but it's allowed to settle out. The sludge settles out, and we have some type of device that pushes the clearer water off the top. And this is why it's known as the clarifier or clarification unit. And really, the last 4, 5, 6, 7, and 8, they can be thought of as a polishing stage. So the maturation will allow some more settling if any sludge is introduced. But the biofiltration, cooling, mixing, pond, and discharge are just pulling more components out of the wastewater that we're not allowed to discharge or we need to process further. So this is an overview. I want to go into detail a little bit more, show you some pictures of how big these units are. So the first one's our equalization tank. So all the wastewater gets brought into this equalization pond, and then it's mixed in this equalization tank, as we mentioned prior, and this is what's going to be shipped to our two oxy ditches. Our oxy ditches look like this. So this is where the real big hit, or the real first treatment happens. They're introduced to our microorganisms here. Here we have a picture of the sludge and the microorganisms on that organic matrix. And here they're digesting the organic carbons in the wastewater. This is the oxy ditch system. This is our CMAS system. And our microorganisms are affectionately known as the bugs. So we need to keep the bugs happy. If we don't, a real good analogy here is if you have an aquarium at home. Let's pretend this is our aquarium and these are our fish. So what are we concerned about? Are we overfeeding our fish? Do we not feed them enough? Is it too hot? Is it too cold? Are there too many? Are there not enough? So we're constantly testing parameters, and understanding this system here especially is going to help later whenever I speak to my specific roles. We run a ton of different analysis, so it helps to clarify why do we need all these different parameters. So that's our oxiditch. That would be step 2. And then we move into, now we're doing polishing. And whenever I think chemical plant and wastewater, I don't think of this, I promise you. So right here, this is our maturation. So if we do get any sludge coming off these clarifier units, it's allowed to settle out here. And it goes through some biofiltration. This is our rock reed. So this is some more, this is indigenous plant life that acts as another filter for the wastewater before it hits our discharge site, our flume. So, and up here what we have going on is during the summer it's hot in Mobile, so we do some evaporative cooling here. And this system keeps our water temperature down. We can't have the temperature elevated too much or we'll create thermal pollution. There won't be enough dissolved oxygen in the water. The final step, this is our discharge site. And so I'll start speaking to my specific roles. This is the final step in our wastewater. So this is where we discharge the wastewater. This has been treated. This comes out the flume about a mile down, and it's discharged on the canal. And when we take this boat out during the summer, about 3 times a week, we go east of this canal site just a little bit. We want to test the dissolved oxygen levels. It has to be over 5 parts per million at 1.5 meters in order to meet the Alabama Department of Environmental Management standards. So I go out there, we use a data son, and I'm going to talk a little bit about what we do with that data. So my responsibilities, aside from just working or going out in the canal and taking data, I've done lab analysis. So day 1, you show up in the lab. We have to test for pH, ammonia, total organic carbon, nitrogen, BODs, CODs, all these acronyms, different analytes. But they're important because we're taking care of our fish. So we need to know the different parameters in order to keep them happy. If they're not processing the wastewater, we can have an issue or a violation on our hand. I've been taking care of a graphical data analysis sheet. This is just monitoring cyanide levels, putting it in a graphical form, turning it into the supervisors so they can get information from it quickly. This data migration spreadsheet I was pretty proud of, and coming up with it was a result of a little bit of heartache. So an employee went on vacation, and while he was gone, I was tasked with putting in the data that was directly captured from our data son. And so we do everything in spreadsheets at the moment. I'm going to talk a little bit about LIMS. It's getting a facelift. We're going to move to a database. But at the moment, it required copying and pasting a line over to the main database. This process could take a really long time. I mean, we're talking about taking data 13 meters deep, salinity, turbidity, temperature, DO, all these different parameters. So I wrote an Excel spreadsheet template that when you import the DataSon data, it would grab it and format it in the same exact way as our main database. So then it became, instead of copying and pasting a line at a time, you just grab the whole line and drop it in the database. So this saved that employee about 3 hours a week, which equates to about roughly $5K a year. Also partner with Bill on TRIs. These are reports that go directly to the EPA. I already mentioned canal sampling. We've been partnered up on points of generation reports. So every time we generate a waste, it has to be tagged. We have to know what's in it. We have to have certain shipping arrangements. What kind of tanker do we need, et cetera, et cetera. And this is the final project that I want to conclude with. We have a LIMS system coming on. This is our laboratory integration management system. And it's a database so we can get away from all these spreadsheets. So this LIMS system is going to be able to grab data quickly, generate reports, do all kinds of things that we need. So I've been just recently taking the analysis we already have and formatting it for a representative out of Promio, making sure he gets the analytes that we run and the formatting that he needs in order to make the data migration a little smoother. So my interns were correct. It's been an amazing experience, and I look forward to continue working in the fall. So I want to give a shout out to Pat and Bill and Justin and every representative at Evonik and APC for the opportunity. It's been awesome. Thank you.